$5, I would charge more.
That is not restriction.
Alright. I mean, if I had a certificate, maybe.
You said I would charge more.
But I may be wrong. I mean, I don't know.
Section 3.6, we're gonna do exactly the same thing. But before we have y equal, let's say 2x. So every time when we need to find the derivative of y, we're gonna multiply by dy over dx. So dy over dx is going to be equal what?
Why?
No, here, for this one, you're gonna say dy over dx equal 2.
Oh, yeah.
If we have y equal 2xy, we're gonna do the same thing. But now, which is the first example of the same thing, I need to find y with respect to which one, which variable, to the x. So I'm gonna find the derivative of y, which is 4y cubed, but I have to multiply by dy over dx. The same thing here, but check here what I have. I have x here, and I need to find the derivative with respect to what?
ER?
To the r. That's mean the derivative of x, which is 4x cubed, times what? Times x
dx to the respective power.
with respect to the variable r, okay? It doesn't matter, like maybe r radius, the volume, the time. So now if you look to the last one, and that's what we call rate. Rate is mean the change of the length of the width with respect to the time, okay? So if I need to find the derivative of x with respect to the t. So now t, we're gonna consider that as a time. So it's going to be 3x squared times dx with respect to the t. And that's what we said is going to be the rate when we need to find the derivative of the function with respect to the time t. Okay? And we can check that with the examples. How it's going to be the rate. So if you look to the first example, assume that both x, y are differentiable fractions with respect to the t. And you already, here's two information. You see, dy with respect to the t and dx with respect to the t. Now what they give you? Y equal square root of x. This is the function. And the information check here. So I already know y equal square root of x. This is the function. The second thing, let's check with A. Find what? dy with respect to the t. So that's what we need to find. At the given x is x equal 4 and dx over dt equal
3.
dx over dt equal 3. So just write down the questions. Now, next step, we're going to work on it. Write down this on the other board so we can solve it. So let's check how we're going to solve this one. So the function y equal square root of x. Now, if I need to find the derivative, keep in your mind, you're going to find the derivative with respect to the t. We're going to find the derivative with respect to the t. That's mean. If I need to find the derivative of y with respect to the t is going to be dy over dt. And that's what we need to find, right? Dy over dt equal. If I need to find the derivative for x, what's the derivative of x? Because this one is the same thing, x to the power 1/2. That means the derivative of x to the power half is 1/2 x to the negative 1/2 times what?
dy dt.
No, dx.
Oh, dx.
Because I'm finding the derivative of x with respect what? To the time. So times dx to the dt.
Which is 3.
Because I'm finding both sides, the derivative of both sides with respect to the time. Okay, so dy over dt equal 1/2 x negative 1/2. Now I need to find the derivative of x with respect to the t, so dx over dt. And here's the question. Now we have x,
Yes.
we have x, we have dx over dt here. Then I find dy over dt.
Yeah.
So dy over dt, you can say, okay, I can write down this 1/2 square root of x. Dx with respect to the t. Now just plug in dy over dt equal 1/2 square root of 4 times 3. How much is going to be the result? Square root of 4 is going to be 2 times 2, 4. 3 times 1, so it's going to be 3 over.
3 or 4.
So 3 over. This is the first one. This is A. Question 1A. Let's check what about B. On question B, we're going to do the same thing, but now we have the opposite thing. We have dy over dt. We need to find dx over dt. So the same thing, exactly the same thing. And of course, they're going to give you a different x. So for B, tell me the information we have. I can see it. Find. Now, they ask you to find dx with respect to the t.
X being 36.
X equal 36.
And then dy dt equals 5.
dy over dt equal 5. And of course, we have the same function, y equals square root of x. So we're going to do the same process. We're going to find the derivative for both sides with respect to the t. That means dy over dt is going to be equal half x to the negative half times dx over dt. Now our goal is to find this side here. dy over dt equal 5. 1/2 plug in 36 to the negative half. You want to plug in here or you want to simplify it? It's also the both is going to be right. It's 1/2 the square root of x dx over dt. So it's going to be 5 equal 1/2 square root of 36 times dx over dt. Here's the variable we need to find. Simplify 1/2 times 6 times dx over dt. So 5 is going to be equal 1/12 dx over dt. Divide both sides by 1/12. That's mean dx over dt is going to be 5 over 1/12. Is that right? You don't know. If I switch the sides, someone asked me why you switch the sides. Dx over dt is going to be 5/1 times what? 12/1. Is that right? Now 5 times 12. How much?
16.
How much?
60.
That's it. Let's do the second one. It's the same process, and you already know how to find the derivative. So tell me, the function is y equal x, no, what?
No, the x will
Y.
xy. Yes, that's nice.
He's testing.
So xy equal 4. Tell me what we have.
X equals 8.
So this is for A. You have x equal 8.
And the dx dt equals 10.
equals 10. What else? That's it?
Find dy over dt.
Okay, so we need to find dy over dt. That's the question. That's the question. Okay, that's nice. Okay, so let's find the derivative here. Because I'm gonna ask you, I'm gonna put space here, okay? Go ahead. How are we gonna find the derivative here? But be careful with respect to the t.
Product.
And this is a product rule. So it'll be the first one times the derivative of y.
dy over dt.
Yes, with respect to the t. Oh, not that one.
Plus,
Plus.
yeah.
Plus the second one times the derivative of the first one, which is
dx over dt.
equal the derivative of 4 is 0. Now let's check here. What we have, what we need to find. We need to find what? dy over. We need to find what?
dy over dt.
Okay. Do we have x? Do we have x?
Yeah, g.
Okay. Do we have y?
Yes. No.
No. Oh, no, we don't have.
How are we gonna find the y?
It's all good.
How are we gonna find the y? So he's looking there. We have x. We need to find dy over dx. We have dx over dt. We need to find
Why?
y. Do we have y?
I mean, if we have X, we have Y, right?
Yes, but how?
We just move it over, so we
Just
plug
move
it in.
Here is y. We have xy equal 4. That's mean y equal what?
4 over x.
4 over x, which is right. You're right.
Why not?
You're gonna plug in 8 here, which is equal 4 over 8. That's mean equal 1 over 2. See, that's the tricky thing with this example. So we have x, but we don't have y. We have to find the y. Okay? So now go ahead and plug it. X is 8 times dy over dt plus y is half times dx over dt 10 equal. What's the next step? Next step.
You just combine those two, then move it to the other side.
Yes.
Nicely.
Can I cancel these?
Yeah.
So 8 times dy over dt plus 5 equals 0. Then move the 5 to the other side. That's mean 8 times dy over dt equal -5. That's mean dy over dt equal -5 over. That's it. Okay. What about next one? They ask you to do the opposite thing. B of what we have, we need to find dx over dt. What do we have? X equal 1
X equal 1,
and dy
DT equals -7.
we do the same thing, the same process. We have x. If you go ahead and find the derivative here, which is the same function here, so it will be x times dy over dt plus what? Y dx over dt equal what? 0. Now again, I'm gonna check what I have. I have x. I have dy over dt. Do I have y? There is no y. So I'm going to plug in y where? Here. That's mean now it's the opposite thing of this one. It's xy equal 4, which is mean. I have the x, which is 1 times y equal 4. That's mean y equal what? Y equal
4.
4. Gonna go ahead and plug in. X is 1 times dy over dt is -7. plus y is 4 dx over dt equals 0. This is negative 7 plus 4 dx over dt equals 0. Move the 7 to the left side. So 4 dx over dt 7. That's mean dx that's it.
Oh, that one. Or that one.
That's one.
Oh, no, or is it?
Oh, no,
the
no.
one-
Here. Emily.
Emily?
Yes.
No, the other guy.
Did I hear my name?
Yes, you see?
Well, yes.
I am.
Hi, Rita.
Let's check the next example. It's x squared. X squared plus y squared equal to what?
159.
And what else we have?
X
The
equals.
first one, we have two options also. A. This is the third. What do we have? Tell me.
X equals 5,
X equal 5,
Y equals 12. Dx dt equals 8.
dx over dt equal 8. And we need to find dy over dt.
Yes.
So dy over dt. Before I start to find what is gonna happen here, who's gonna tell me what's this?
What is that? Is a constant.
Number 3?
Every point counts in math, so I mean,
So let's see, this is the problem.
Right.
Y equal tangent. I love tangent. Tangent. What do we have?
Dx dt equals
X over dt equal what?
6 feet per second.
6 feet per second. Okay.
And then x equals negative 5.
Oh, okay. They make
We're
it easier.
solving for dy.
X equal,
Negative 5 over 3.
this is only A. Now we need to find what?
dy over.
We need to find dy over dt. So here is the function, y equal tangent x. That's mean what? dy with respect to the t equal what? Secant
Secant
square x
times dx dt.
and we have the x over dt. So let's simplify it. That means dy over dt equal, this one is what? Secant square x times what?
6.
6, okay. What's the next thing?
We put secant squared negative pi over 3.
Oh, yeah. But be careful, you're not gonna multiply 6 with the x.
That's
This is an angle, this is a number, so just type it in the front. That means dy over dt is going to be equal 6 secant square, how much the x? Negative pi over,
negative 5 over 3.
there is the thing. Now, the whole thing you have to use now calculator to find how much is going to be dy over dt. Now tell me, this is 6. How are you gonna find in the calculator of the secant square negative pi over 3? Go ahead, can you plug in?
And bring the calculator to them.
Calculator? No. So to plug in, because the secant x is 1 over cosine x. I cannot plug in cosine. Yes or no? I cannot plug in 1 over cosine, because cosine x, I have it in the calculator, so 1 over cosine x. Now, what about if you have secant square x, 1 over cosine square x. You're gonna plug in negative pi over 3 here. Square, that means cosine times cosine. Plug in cosine, which is 1 over cosine x, cosine x. Plug in pi over 3 here, cosine, and plug in pi over 3 cosine, multiply these. 1 over these is going to be the result of secant, which is here. Then the result you have to multiply by 6. You're gonna get the result. You got it? Let's take this example. So the radius of the circle increasing.
Yeah, I got 4 and 4.
Oh, you have to make a decision.
Among your peers.
So the radius R of the circle increasing at the rate 2 centimeters per minute. What's that mean? You see, they're not gonna give you anything. You have to figure out. It's a rate. It's a rate. They're telling you an increasing in a rate. How much
2 centimeters per minute.
per minute? What's that mean? The radius increasing in a rate 2 centimeters. That means the change of radius with respect to the t equal what? 2. You got it? Because the radius, it's a rate. That means the derivative of the radius with respect to the time equal what? 2. That means the radius of the circle change. 2 centimeters per minute. Find the rate of change, the area. What's that mean? The change of area. That means the derivative, we need to find the derivative of area with respect to what? To the time. That's what we need to find. When the radius equal what?
38.
38 centimeters. So you see, you need to find the information. That's the cool part. Yeah, the change of radius with respect to the time 2, the change of area with respect to the t, that's what we need to find. We have the radius, so we have only the formula, the area equal what?
Area.
Pi
Pi r squared.
r squared. This is how to find the area of the circle. So let's write down this information here, which is we have dr over dt equal 2, and we need to find dA over dt, and we have the radius equal 38. What we need to find? Okay. So the formula is going to be what?
Pi r squared.
A equal pi r squared. Now I'm gonna find the change with area. That means the derivative of A with respect to the t is going to be pi. Don't worry about the pi, it's a constant, times the derivative of the radius 2r, the derivative of the radius with respect to the time. We have radius, we have the change of radius with respect to the t, so we're just gonna plug it. Equal, here's pi times 2, r is 38, times the change of r with respect to the t is going to be 2. So dA with respect to the t is going to be equal 4 times 38 is going to be what?
Pi.
Just keep it pi. Don't worry about the pi. I think they're gonna accept it. 152 pi. So the change of area is going to be 152 pi centimeter per
Man.
minute. Squared. Centimeter squared. Should be, because it's an area. That hard. That means this is the change of radius with respect to the time,
So the time.
which is dr over dt equal to find the rate of change of the volume when the radius is equal to 10. So we said that the area of the for the sphere equal what?
4/3, you said?
Of the volume, so not the area,
Oh, the volume.
the volume of the sphere. Because we said 1, 2, 3. So the volume equal 4/3 pi r cubed. We need to find what? dV over dt. The change of the volume. So that's mean dV with respect to the time equal 4/3 pi times what?
Which is R10.
3 r squared dr over dt. You lost?
Oh, okay. So on myself.
So I have the radius. I have dr over dt. Can I find dv?
Yes. Yes.
dv over dt is going to be 4. We can cancel the 3 with the 3. So it's going to be 4 pi. The radius is 10 square. And dr over dt is 2. That means dv with respect to the t is going to be what? 100 times 8.
It's easy enough.
What?
That seems easy enough.
Yeah, it's not that much hard. But the main thing, you have to know the formulas. What about the second one? You're gonna do the same thing? You're gonna use the same formula because they're telling you.
Volume.
What about if they're not telling you?
Spherical balloon is inflated with
Okay, with that at rate.
800 cubic.
So what's that?
centimeters.
What's that when they're telling you?
And it's.
That
Volume is
the-
changing,
What?
800 cubic.
So you have two options. Find the rate of change with the radius. So they're telling you here, find the rate of change with the radius, okay? Because I need this change is with what?
That's the volume.
That's the volume. Because they fill the balloon with the gas, that's mean the change is going to be what? With the volume. Okay, so this is the change of, that's what we need to find. The change of volume with respect to the T. Find the rate of change. No, we have it. We have the change of rate with respect to the T, which is
800
800.
on the area.
Yeah. And not the area.
No,
The radius, the rate of change with the radius. So we need to find dr over dt, and we have the radius equal 70. Come on, we're gonna use the same steps. The volume is equal what?
Equals 4/3
Pi
cubed.
r cubed. That's mean dv with respect to the t equal 4/3, and here is pi times 3 radius square dr with respect to the t. That's mean dv with the t equal what? Or cancel the 3.
4 pi r squared.
4 pi, and r squared is 70 squared. Yes or no? Yes.
Yeah.
And we need to find the radius with respect to the t, because we have the volume. $800. 70 square, how much going to be? 4900? Not sure, yes or no?
Yes.
Maybe. Times 4.
You made me wrong, I don't know.
Go ahead, check it, times 4.
Calculator. So 737.49. It's 2 zeros. Yeah.
19,600.
19,600. Pi, don't forget the pi,
Oh, no, there's one more zero.
600, oh yeah.
Alright,
600 pi. dr over dt. Finish the test here. dr over dt is going to be equal what? 800 divided by 19,600 pi. Cancel these two zeros. How much going to be?
0.04.
1, 0, 4,
0.04.
1.05,
Alright,
yes. Oh, they give us two ideas. You have 70, you have 95. Okay?
you just do the same thing, but put 95.
Yeah. Same, same. For the volume, the formula is going to be what? The volume for the cube. The volume is going to be size cube. That's what we need to find what? All ages, all depending outside what?
978.
That means the side, which is ds, with respect to the t equal 9. Because the length, the width, and the height is change how much? At 8. Okay, now we need to find the volume. That's mean dV with respect to the t. What else do we have? Do we have the side?
1 centimeter.
So S equal. Okay, we're gonna go back here. dV with respect to the t equal 3 side square ds with respect to the dV with respect to the t is going to be 3 1 square times what? Times 9. It's going to be what?
27.
That have. Can you do the same thing when you have 13 centimeter? You're gonna plug in 13 instead of 1. That's it. Piece of chocolate.